We're covering our last chapter this year on acids and bases. And the other day we talked about different definitions for acids and bases, Arrhenius versus Bronsted-Lowry. We also talked about properties of acids and bases, and we did identify strong acids and strong bases. And we'll talk a little bit more about strong acids and strong bases today as we introduce the concept known as pH. Now think back to middle school, or maybe just from your basic bio class that you took. What do you know about pH? Go ahead, Sam.
If it's higher than 7, it's really basic. If it's lower than 7, it's really acidic.
All right, so a pH less than 7 is acidic, a pH greater than 7 is basic, so a pH of 7 represents neutral. And water at a certain temperature does have a pH of 7. What else did you learn? That's all you learned about pH? Did you ever do any type of lab with pH paper?
Yeah.
Cabbage juice is a natural indicator. It is. Cabbage juice is a natural indicator. It's purple cabbage, though. It has an interesting smell because, well, you have to boil it to get the juice out. No worse than a gym. That's all you remember? Good, then you're going to learn something today. We're going to talk about pH, which you may or may not know represents power of the protons. Do acids or bases generate protons when dissolved in water? Acids. Acids generate protons when dissolved in water. Those would be your Arrhenius acids. And the Bronsted-Lowry acids donate protons. So pH is an acidity scale. It's going to indicate how acidic an aqueous solution is. You can also get a feel for basicity based on the pH that the solution has. pH can be calculated as negative log of the concentration of proton. As you said just previously, the pH of a neutral solution is 7. If the pH is less than 7, the solution is acidic. If the pH is greater than 7, the solution is basic. What you also can tell from pH values is that a solution with a pH of 2 is more acidic than a solution with a pH of 5. Now, strong versus weak acid is different. A strong acid ionizes completely. pH scale here, you're just talking about making a comparison of whether something is more acidic than another solution.
Is the log going to be always base 10 or no? You just not get it.
Yes, log base 10 as opposed to natural log ln.
Okay.
Yes. And so
No,
if...
no, I mean like, because you know how it's like log and then the base underneath it, if it doesn't have a base and it's 10, or will it just like have a little number like 3 or something?
No, it's always going to be base 10. And of relevance there, and I don't know, it's a good question because we can calculate pH that way, and you're going to see that you can calculate proton concentration as 10 to the negative pH. So yes, they are related, and I've learned from the kids over the years that I do math very differently than you do based on how I learned without a calculator compared to how you learn today. And if we get there today, I'll show you what I mean by proton concentration. I learned that as anti-log, and I don't believe it's taught that way anymore. And when we get there, I'll reference it. But yes, base 10. But not like you need pre-calc or anything to do this. Yeah, a lot of this you can do in your head, and at the AP level, you have to be able to do some of it in your head, and I'll show you some tricks this year, so when you see it again next year, you'll be good to go. In any event, everything I said before is right there. So a solution with a pH of 13 is more basic than a solution with a pH of 9. Here are some common substances and their pHs, as well as indicating whether they're acids or bases. For example, 0.1 molar hydrochloric acid has a pH of about 1. It is an acid. In your stomach, you have hydrochloric acid. Your stomach is very acidic. That's why some of the eating disorders are very, very much a concern for your esophagus as well as your teeth. For people with bulimia who throw up excessively, that stomach acid is going up the esophagus and then it's touching your teeth, and it will eat away at the enamel, especially on the back of your teeth. That's what a dentist will often look at to make sure that you're not hurting yourself in any way. But stomach contents have hydrochloric acid. If you have an upset stomach, you can take Rolaids or Tums or any of those antacids, and those antacids are bases. They're essentially magnesium hydroxide, which is a weak base, and that will neutralize stomach acid. Also with the reflux, a lot of people have these, I guess it feels like heartburn, but it's not your heart that's affected. Acid reflux, and you see this a lot in babies nowadays, which is a little surprising. Or very often people with acid reflux, they'll take, yep, that's one of them, and there's something else. Yeah, usually it's the parents. I know, like with my daddy. What have you been doing in the medicine kit? No, I'm just kidding. I was kidding. Not this one. We're on film. In any event, those will help neutralize stomach acid. And so if the flap isn't closing properly, yeah, the acid's kicking back up, and that's causing the burning. Oh boy. Vinegar has a pH of about 3, as does soda. That's why you don't drink soda for breakfast. It's not good for you. It's like pouring a can of acid right into your belly.
What? I don't have anything on my desk.
I have been trying to impress upon my husband for years that soda is not a good beverage for breakfast. And for that matter, just a cup of coffee is not so good either. Coffee's acidic as well. Grapes, pH of about 4. You're too young to drink beer. Bread, 5.5. Urine, slightly acidic at 6.6. As you would expect, your saliva is neutral, pH of 7. Bread is slightly acidic, not significantly.
I thought the saliva was slightly acidic.
Maybe if you're spitting stuff up from your stomach. But no, your saliva.
Because don't they say that's
Well, we'll try it. I'll spit on something and put a pH strip in. Why not? Well, just drinking coffee for breakfast without anything else is just putting too much acid. All of these drinks, well, I don't want to say they're all fine, because I personally don't think children should drink soda or coffee, but that's a personal mommy opinion. As long as you eat something with that acidic beverage, it's fine. But just to have that acidic beverage first thing in the morning, you have nothing in your system to neutralize it. Or do you drink coffee for breakfast?
Me?
Yeah, go ahead.
No. But I don't know if this has anything to do with this, but how come when you get like a jellyfish stain and you pee on it yourself, how come it like helps it?
What?
Yeah, that's the thing.
It's like a surfer
If you
thing.
get stung by a jellyfish, you pee on it.
It's either that or put vinegar
Or
in
vinegar,
it.
yeah.
All right, well, let's think about it. So,
Something like that.
well, I think you've got it already. So, I've never heard that. So, if you get stung by a jellyfish, you're told to pee on yourself? Wonderful.
Or if you like pee on like what if you get like
It's
some
really hard to
shoulders
pee on
that has
yourself.
pee is like pee is sterile.
Let's answer her question. It has nothing to do with whether it's sterile. Based on the fact,
Just saying it's really hard to do by yourself.
Make sure you have a close
Nick, where did you hear that you put vinegar on it?
That's what you're supposed to.
I got stung by a jellyfish and the lifeguard's like, here, do you want me to pee on it or put vinegar on it?
All right. I personally would pick the vinegar, but hang
I
on
pick
one sec.
vinegar.
I'd rather you pee
It
on it.
burns.
That jellyfish, now I've never heard of this, but it makes sense with acid-base chemistry. That jellyfish sting must be basic. So by adding something acidic to it, you're neutralizing that basicity of the sting. I don't know what it is that they're secreting that's so bitter, but that's something we can look up and talk about. But based on what you've told me, you add acid to neutralize it. So that makes sense. Although urine's not terribly acidic.
You said yes or no.
When you
The jellyfish sting likes
to get like a little spritz bottle, like filled with vinegar, and just spray yourself down.
And that's
you
probably
can't
for the
lose off
same
for 10
reason.
minutes at first.
So whatever they're secreting into your system must be basic in nature.
Okay, I looked it up. It says human urine
She's on her
has
phone.
a pH of 7. And then jellyfish venom, hold on, give me a sec.
Scroll to
It says that it varies with different jellyfish.
But what's the range?
A box jellyfish is probably way up there.
It's slightly acidic.
That doesn't make sense.
What?
No, it doesn't.
So maybe your pee's basic.
No, it says P is acidic.
No, P is acidic.
It might be because like P is like kind of neutral.
It is.
No, because if you spill acid on yourself, well, you put vinegar on it.
Jellyfish venom is slightly alkaline. And
Alkaline, which means basic.
Oh well, it said acidic.
No,
Oh,
alkaline.
No, it says human. Okay,
Yeah.
Never mind.
So that's what it is, and it makes sense. So whatever they're secreting into you must be basic in nature. In regard to the vinegar, vinegar is 5% acetic acid, so vinegar is acidic. When you go to neutralize something, for example, if you were to spill hydrochloric acid on you, I wouldn't take strong base and spill it all over you. I would use a weak base to spill on you, and that's why baking soda, and this gets into more complex material than you want to talk about at the honors level, but baking soda is slightly basic in nature, and that will neutralize the acidity of whatever acid you've spilled on you.
Wait, but hydrochloric acid is a pH of 1.
It depends on the concentration of it. It's a strong acid ionizes completely, but if you compare the concentration of 0.1 molar hydrochloric acid with 1 times 10 to the negative 5 molar hydrochloric acid, they don't have the same pH, and I can prove that to you in a minute as soon as I show you how to do it. All right? Blood has a pH of about 7.4. Those of you in medical, did you learn about acidosis or not yet? Do you know what acidosis is? No? Well, blood typically pH of 7.4, and it's very important that the blood pH stays within a certain narrow region, because that is the pH at which bodily functions, organs operate best at. So if you get a significant alteration in blood pH, that can affect any type of biochemical pathway in the body, organ function, etc. When blood pH goes too low, acidosis can set in, and that's a severe medical condition that we won't get into at this point. But the body is buffered to prevent fluctuations in pH. Ammonia has a pH of about 11. You tend to clean with bases. They're very slippery, so you can get off grime. And sodium hydroxide at 0.1 molar has a pH of 13. And I'm going to show you how to go from the concentration of a strong base to the pH, the concentration of a strong acid to the pH.
Is there anything with a pH of 14?
1 molar sodium hydroxide would.
What would you use that for?
That's what I usually pour down the drains.
Oh.
Drano, essentially. All right, we want to get into how to calculate. I will give you all of these formulas, so you don't have to memorize them. I'll give them to you for your quiz, your test, your semester exam as well. All right? Is it about PP?
No,
Okay.
no. Her question was, what would happen if you drank vinegar and had baking soda at the same time?
No, that was not my question.
Yes, it was.
Well, one thing you do want to be, like, you never want to see babies sucking on lemons. Lemons are very acidic, and it will eat away at their baby teeth like crazy.
Wait, if you did.
And like kids drinking soda, like my kids don't drink soda. We don't have soda in the house, except my husband's. And Sam tried it one day, and she thought it was disgusting.
Creates bubbles, starts fizzing, you probably
Oh, you want to hear Michael's question? What?
Let's get back on topic. So glad I filmed today. pH, negative log of the proton concentration. pOH, negative log of hydroxide ion concentration. The sum of the two is 14. Couple things to remember here. If you want to know pH and you're given the proton concentration, use this formula. If you want to know pH and you're given the concentration of a strong monoprotic acid, you're going to use this formula. If you're given the concentration of hydroxide ion and you want to know pH, you'll do this first, then this. If you're given the concentration of a strong base, you'll need this formula. You may or may not need a stoichiometric conversion. I'll show you that. And then again, you'll get pH from here. So we're going to go through a series of examples. It's very important that you plug into your calculator to make sure you know what you're doing with your calculator. I can help you with your calculator today, any day we do classwork. But I can't punch your calculator on a quiz or a test. That's not fair. The proton concentration of a solution is 1 times 10 to the negative 4 molar. We want to calculate the pH of this solution. We want to know if it's acidic or basic, and we want to explain the choice that we've made or justify our choice. When given proton concentration, you just do negative log of it. If you have this calculator, you very simply plug as is. You've got negative log 1.00, you don't need the 0.00. EE, negative 4, and that's going to be 4. If you have this multi-view, you're going to do negative log 1.00, the times 10 to the n, negative 4, take it to the side, close, equals. If you have this, you're going to do everything backward. Does anybody have this? So what you're going to do with this calculator is you're going to put that concentration in. You're going to hit log and then the plus minus button. So make sure you're comfortable with your calculator. That's very, very important because some of the kids weren't good with their calculator on the last quiz. All right. Another thing I want to show you are the sig figs. So in the problem that I gave you, the proton concentration was 1.00 times 10 to the negative 4 molar. We know the pH is equal to the negative log of the proton concentration. If you have a number that is 1 right here, if you have 1 before the times 10, nothing after the 1 except zeros, then the pH is equal to the absolute value of the exponent. In regard to the sig figs, you have 3 sig figs here. You will put 3 zeros after the decimal point. For pH and pOH, the sig figs start after the decimal point, so it's a little bit different. Well, you can always use your calculator this year on your assessments. I do just want to indicate that if you have a number greater than 1, let's say 3.75 times 10 to the negative 4, the pH will be 1 less than the absolute value here with 3 digits after it. So for those of you going to AP, you have to be able to do this in your head. You don't have to know what those digits are, but you'd have to know you're dropping down 1. And when you go to AP, we'll spend more time playing there. In regard to your sig figs, 3 sig figs 3 digits after the decimal point for pH and pOH. So if you're given proton concentration, it's pretty straightforward. In your notes it says if you have a strong acid, the concentration of acid is equal to the concentration of proton because the acid ionizes completely, generating 1 proton. Now that's not the case for sulfuric acid. We're not going to play with sulfuric acid this year in this type of calculation because it's too tricky. But one thing I do want to show you again, for example, if you have hydrochloric acid, regardless of its concentration, hydrochloric acid is a strong acid, which means it ionizes completely. The concentration of hydrochloric acid will be equal to the concentration of proton. So if you're given the concentration of hydrochloric acid, that will be the concentration of proton, and you can get the pH by doing negative log of that concentration. This is the case for every strong acid except sulfuric acid. So if you look at nitric acid, and next week you're going to learn how to name the acids, this acid also ionizes completely. It's a monoprotic acid. It has 1 ionizable proton. So these concentrations are going to be the same. So instead of giving you concentration, I could give you, instead of giving you the concentration of proton, I could give you the concentration of the strong acid. And that's what I'm showing you here. The concentration of nitric acid is 3.2 times 10 to the negative 3 molar. Calculate the pH of the solution. Is it acidic or basic? So the concentration of the nitric acid is 3.2 times 10 to the negative 3 molar. That's given. Why is that equal to the concentration of proton?
Because it ionizes, but it's a monoionized.
It ionizes completely. It's a monoprotic acid. It has 1 proton. Because it ionizes completely, the concentration of this strong acid is equal to the concentration of proton. Then you do negative log of that concentration. Again, a number greater than 1, the pH will be 2 point something, shown here. 2 sig figs. 2 sig figs after the decimal point. The solution is acidic because the pH is less than 7, and the same held true. If you were to compare this first pH with the second pH, we know they're both acidic because the pH is less than 7. Which solution is more acidic? The second one. Why? It has a lower pH. The lower the pH, the more acidic the solution, the farther from neutrality. All right, let's do this one together from scratch so that you can watch it. And you'll get a lot of practice with these, and that your quiz will be focused in this area as well as the conjugates we talked about the other day. All right, so on this one, we're given the concentration of chloric acid, and that's 5.46 times 10 to the negative 2 molar. We want to know the pH of the solution. First thing I do, is this a strong acid? Yes, and I'm just going to give you strong ones on the quiz, so it's not going to be an issue. Well, if it's a strong acid, that's equal to the concentration of what? Proton. So we've got pH is equal to negative log of 5.46 times 10 to the minus 2 molar. And again, make sure you're comfortable with your calculator. And that's going to be 1.263. Is this an acidic or a basic solution?
Acidic.
Why? pH is less than 7. Good. So that's how you deal with strong acids that are monoprotic. Haley?
I know it's extremely acidic.
It's not if it's extremely acidic. There are 8 strong acids that you want to be familiar with. They're in your notes. I'm going to tell you on the quiz that it's strong, but on the test you could have a multiple choice question. Which of the following is a strong acid? Your strong acids are hydrochloric acid, hydrobromic acid, hydroiodic acid. Those are the 3 strong binary acids. You've got sulfuric acid. That's a ternary acid, 1, 2, 3 different atoms. This also is diprotic. It has 2 ionizable protons. Nitric acid, chloric acid, perchloric acid, that's a 3 there, that's a 4, and periodic acid.
Let's say we didn't know any of those 8. How would you be able to tell whether it was a strong acid or a weak acid?
Just from looking at it,
Yeah.
you wouldn't be able to tell.
You just have to know.
You need to memorize it. The only way you could tell is if you have a strong acid and an equation was shown, the forward arrow only indicates that it goes to completion. This would be AQ for aqueous. Whereas a weak acid, such as phosphoric acid, would be an equilibrium reaction in which the reverse reaction is favored. As such. So that's the only other way you'd be able to tell. Goes to completion, that's strong. Equilibrium reaction or reversible reaction, this is weak.
Why is the reverse reaction favored now?
Because when you look at the concentration of the acid as compared to the concentration of proton, the concentration of acid is significantly higher. This holds on to its proton much tighter than this. I don't know if I showed you that little video. I thought I did. It's in your notes. I can come back to it. You actually can see it at the molecular level. But other than memorizing your 8 strong acids, and these are all from group 17, or seeing an equation, I don't see how else unless they gave you concentrations. See, you can, to figure out the pH of this, it's easy because this is equal to this. And then when you go to advanced chemistry, to figure out the pH of this, you first have to find this concentration, which is going to be significantly less than this. So that's a little more involved, but not impossible. All right, so for the strong acids, or if they give you proton concentration, very straightforward, pH is equal to the negative log of the proton concentration. In contrast, if you're given either the concentration of hydroxide ion or the concentration of a strong group 1 base or the concentration of a strong group 2 base, with one caveat here which we'll get to, when they do this to you, you're going to solve for POH and then you'll convert to pH. So when you have an acid or proton, poof, you go right into pH. But if you're given the concentration of hydroxide ion or a strong base, you're going to have to get POH, then pH. So let's take a look there. And you know bases have a pH greater than or less than 7.
Greater.
Correct. Alrighty. It says concentration of hydroxide ion is 1 times 10 to the negative 2 molar. We've got 3 sig figs here. Calculate the pH of the solution. Is it acidic or basic, and why? if they give you hydroxide ion concentration, you're going to get the POH. POH of 1 times 10 to the, POH is equal to negative log of that concentration, and that's going to be 2.000. Again, 3 sig figs after the decimal point in POH because of the 3 sig figs in the concentration. Once you get the POH, you'll subtract it from 14. Maintain those sig figs from POH to pH even though the 14 doesn't have the sig figs. So this is a basic solution with a pH greater than 7. Just the way we did acids, you can do the bases. So for strong group 1 bases, those concentrations are going to be the same. For example, we know strong bases ionize completely. So if you have sodium hydroxide, that's going to generate sodium ion and hydroxide ion, and these concentrations will be equal. Be careful, if you have a strong group 2 base, of which there are 3 that you'll need to know, but in this situation I would tell you, for every 1 mole of strong base, calcium hydroxide, how many moles of hydroxide ion do you generate? 2. So this is a little trickier. We'll get there in a minute. But if you have a strong group 1 hydroxide, and all group 1 hydroxides are strong, these concentrations are equal. So if they give you the concentration of the base that's equal to the concentration of hydroxide ion, the negative log of that will be the POH. Subtract it from 14 to get the pH. And that's what's shown here. Sodium hydroxide concentration is 1.4 times 10 to the negative 3. This is a strong base, so that also is equal to the concentration of hydroxide ion because of the 1-to-1 mole ratio we showed. POH is equal to the negative log of this concentration. The POH is 2.85. Subtract it from 14, and you will get the pH, which is 11.15, a basic solution with a pH greater than 7. Let's try this one together. I'm going to put it on paper for you. Concentration of cesium hydroxide is 2.4 times 10 to the negative 4 molar. We want to know the pH, whether it's acidic or basic or why. First thing you're going to recognize is this is a strong base that ionizes completely. It's got 1 hydroxide ion in it, so this concentration is also equal to the hydroxide ion concentration. Does that make sense? So POH would be equal to the negative log of what? 2.4 times 10 to the negative 4 molar. The POH is going to be 3 point something. 3.62. But they asked for the pH. So how do I get the pH?
Subtract that from
14 minus this, and that's 10.38. Why is this solution basic?
Greater than 7.
Pretty straightforward? Yes, yes? Yes? Easy peasy? All right, let's try the harder one. Make sure you can do it. In the next example, I gave you one of those strong group 2 bases. Calcium, barium, and strontium hydroxide are all strong bases. But you have to be careful because for every 1 mole of those, you generate 2 moles of hydroxide ion. And this is one of the things I like so much about the acid-base chapter. It requires you to review solutions and stoichiometry, which are topics that we covered in the third 9 weeks, which will be assessed on your semester exam. So this will bring you back to it. Concentration of calcium hydroxide is 1.4 times 10 to the negative 3 molar. We want to calculate the pH of the solution. We want to know if it's acidic or basic. So the concentration's given. It's a strong base that ionizes completely. What's the mole ratio of calcium hydroxide, the base, to hydroxide ion? 1 to 2. And that's a very easy type multiple choice question you could see on your semester exam. We have the concentration of the base. To get the concentration of the hydroxide ion, we've got to take into account that 1 to 2 mole ratio. So the concentration of hydroxide ion is 2.8 times 10 to the negative 3rd molar. pOH is negative log of that. And again, if you have a base, you're going after the pOH first. So the pOH is 2.55. How do I get the pH? 14 minus the pOH. Here's your pH, a basic solution with a pH greater than 7. Looking at the one in purple, you want to give it a shot? Try it. I'll do it too. Say what? We have plenty of time. How'd we do?
What's the answer?
Look good? Did you remember this piece?
Yes.
Easy peasy? So in these problems, I gave you the concentration of the base. What if I gave you the mass and the volume of the base? Could you get the concentration?
Yes.
Yes, you can. And this is going to link back to our solution chapter. Ready? In the next problem, we've got the mass of the acid, and it's dissolved in a final volume of 750 mils of solution. You want to calculate pH and then see if it's acidic or basic. Let's give it a try. So this is grossly similar to what we just did. We're just taking one step back. So the mass of the nitric acid powder that you have in the chemical storeroom is 0.371 grams. And the total volume is 751 mils. You want to calculate the pH. Well, to get pH, we need to get proton concentration. To get proton concentration, we need the concentration of the nitric acid. Concentration is going to be the moles of the solute over the total volume of solution in liters. And that goes back to our solution chapter. So if I have the mass of the solute, can I get moles? How? How do you convert it? Periodic table. 1 mole of nitric acid is equal to its mass in grams from the periodic table. I'm going to flip that into scientific notation because it's easier. And it's okay if the moles are really little. And what will you divide that by? 0.751 liters. Mils to liters, move the decimal 3 to the left. And the concentration is 7.84 times 10 to the negative third molar. Why is that concentration equal to the concentration of proton? Because it's a strong acid. It ionizes completely. So how do you get the pH? It's going to be 2 point something. Why is this solution acidic? So what we did in this problem is we went from mass and volume to concentration, first converting the mass to moles. Once we got the concentration of the strong acid, we knew it was equal to the concentration of proton. pH is negative log of the concentration, and with a pH less than 7, the solution's acidic. Questions there? I would like you to try and do number 7. Give it a shot. It's got to be about 36 and a half. How'd we do? Pretty good? It depends where you round it. It's okay. So if they give you an acid, you go through pH. If they give you a base, you go POH to pH. You want to be careful there. On your classwork, this is a little tricky because you can do some of the table but not all of it. But you can do 15 through 19, with 18 and 19 being similar to what we just did. So you can do some of the table. And you can do 15 through 19. All right, so what you want to be comfortable with today is how to calculate pH and POH from either the concentration of proton, hydroxide ion, strong acid, or strong base.